Alrighty, friends, back for 3.5. We're actually skipping 3.4 and jumping straight into 3.5, which talks about isosceles and equilateral triangles. So, a couple new vocab that we're going to talk about: legs and base of an isosceles triangle, vertex and base angles, what a corollary is, etc. Okay, so an isosceles triangle, which hopefully you know, means that there are two of the sides that are the same length. Okay, isosceles triangles are common in the real world. You can see them frequently in structures such as bridges and buildings, as well as in art and design. Okay, so the two congruent sides, we call those two sides the legs. And then the other side is called the base. So we have two legs and then one base. The base doesn't always have to be on the bottom. The base is just whichever one is not congruent to the other ones. Okay, and then similarly to the sides, we have two base angles. So those are the angles that are attached to the base. So if you look at the figure over here, they're the ones on the bottom. And then the other angle, which is in between the two legs, is called the vertex angle. Okay, so vertex angle and two base angles. Okay, and that takes us to our isosceles triangle theorem, which says that if two sides of a triangle are congruent, so if you have an isosceles triangle, then the angles opposite those sides are also congruent. So what it means when it says the angle opposite those sides is it means the angle that's not touching those sides. So for example, the angle opposite of this side would be B. The angle opposite of this side here would be A. So your two opposite angles, A and B, your two base angles are going to be congruent. So if you have an isosceles triangle, then the two base angles are always congruent, is basically what the isosceles triangle theorem says. And then there's also the converse of the isosceles triangle theorem, and when you're doing the converse of a theorem, you're basically just switching the if and the then statement. So this says, if you have two angles that are congruent, then their opposite sides are also congruent. So basically, if you have two angles of a triangle that are congruent, then you know that that triangle is isosceles. Okay, so this one says, is AB congruent to CB? And how do you know? Explain. So AB is this whole side right here. Is that congruent to CB? Well, if you notice, we have one mark here and one mark here. So we know those two triangles, or those two angles are congruent, which means by the converse of the isosceles triangle theorem that yes, these two sides should also be congruent. So yes, by the converse of isosceles triangle theorem. Isosceles triangle theorem. Some pretty bad abbreviations, but anyway. So that one we use the converse because we use the angles to show that the sides were the same. Okay, the next one asks about the angles. It says, is angle A congruent to angle DEA? So angle A is this one right here. Is that congruent to DEA, which is that one right there? So if you look at the smaller triangle, we know that this side and this side are congruent. So we have an isosceles triangle, which means that the two base angles are congruent. So A does have to be congruent to DEA. So yes, and that one we use the sides to show the angles are congruent. So that's just the isosceles triangle theorem. Okay, so if you use the sides to show the angles are the same, that's the isosceles triangle theorem. If you use the angles to show the sides are the same, that's the converse. Okay, but your two base angles of an isosceles triangle will always be the same. Okay, so is WVS congruent to angle S? So angle WVS is this one right here. Is that congruent to angle S? Well, this is a very similar shape to the one we just had. And if you notice, we have two dashes there, so those legs are congruent, so it's isosceles. So yes, they are. Your base angles are congruent by the isosceles triangle theorem. And then the last other question, it says, is TR congruent to TS? This one, we just showed that these two angles are congruent. We also know that this angle is the same as this angle, which makes it the same as that angle. So because we have those two angles the same, R and S, here and here, we know that the opposite sides, so this one right here, TR and TS, are indeed congruent. Man, I'm struggling writing. By the converse of the isosceles triangles theorem. Okay, we'll skip that next question. Okay, An isosceles triangle has a certain type of symmetry about a line through its vertex angle. Okay, so if this is theorem 22, it doesn't really have a specific name. It says if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So if the line cuts the vertex angle in half, then it also cuts the base in half at a right angle. So because we know that this line right here, CD, cuts our vertex angle C in half, that tells us that it should cut AB in half. So these two sides are congruent, or those two pieces are congruent. And then it also forms a right angle with the base. Okay, so that's why you get your right angle there. Okay, so using that information, we can figure out what the value of x is in this problem. So you know that DB cuts angle B in half, and B is your vertex angle, because you can see the two marks there and there. So it cuts it in half, so that tells us that this should be a right angle here. If I can draw a right angle. That's a right angle, which means the opposite one, the other one, adjacent one, is also a right angle, since they form a straight line. So, knowing that, we know this angle right here, A, is 54, because I'm assuming that's what it's talking about anyway. And we know this is a right angle, so that's 90 degrees. A triangle should always add up to 180. So to find your missing, we can find that missing piece there by doing 180, subtract 54, subtract 90. And that should give you like 36, I think. 180 minus 54 minus 90. Yeah, 36. So this angle right here is 36 degrees. And because we know it's going to be the same as this angle over here, that tells us that x should equal 36 degrees. Okay. So that's how you can use that theorem to show that it forms a right angle, and then solve from there. Okay, suppose the measure of angle A is 27. So basically the same question here, we're just changing it to 27. So I want you to go ahead and try that one, and you can pause this in 3, 2, 1, pause. Okay, so since this is 27, we do 180 minus 27. We know that this is going to be a right angle, because it forms a perpendicular line, because it cuts the B in half. So minus 90 as well, and we get 63. So that tells us that both of these angles here and here should be 63. So x equals 63. Okay. And then we have a couple of corollaries. A corollary is basically a simpler theorem, or a theorem that can be proved easily using another theorem. So it's very similar. It's a very similar theorem to one we just did. So for example, the corollary to theorem 20. Theorem 20 was the isosceles triangle theorem. So the corollary to theorem 20 says if a triangle is equilateral, then it is also equiangular. So if you have an equilateral triangle like this, then all of the angles should also be congruent. So this angle is the same as that angle, is the same as that angle. And actually, because it's equilateral and equiangular, we know that all the angles should be the same. Since they should all add up to 180, we can just do 180 divided by 3 to get 60. So for an equilateral triangle, the angles are always 60 degrees. Okay, and then the corollary to theorem 21, theorem 21 was just the converse of the isosceles triangles theorem. It says if a triangle is equiangular, then it is equilateral. So if we know that each of the degrees is 60, because they have to add up to 180, then the triangle is equilateral, so all the sides are the same length. So those are very similar to the isosceles triangles theorem and the converse, because now you're just using 3 sides instead of 2 sides. So all 3 sides are congruent. Okay, this one says, what is the measure of angle A, angle B, and angle ADC in the photo? So if you notice, all of the sides have the same mark. They both have 1. So that means it's an equilateral triangle. And like we just said, the angle of an equilateral triangle should be 60. So every angle should be 60. So A is 60, B is 60. ADC, though, ADC is actually this whole angle here. So ADC actually is this angle combined with that angle. So it's actually 2 60-degree angles. So 60 plus 60 gives us 120 for angle ADC. okay, because you're adding those two angles together. Oops. Okay, and that was just convenient because you have three equilateral triangles. The next problem here, it says, suppose the triangle in problem 3 are isosceles triangles, so they're not equilateral, they're isosceles, where angle ADE, DEC, and ECD are the vertex angles. If the vertex angles each have a degree of 58, measure 58, what are the measures of angle A and BCD? So now we're saying that this angle here is 58 degrees, and we want to find A. So what is that angle, and then what is this angle here, BCD? So what is that whole angle? Okay, so to find A, first thing we want to do is we know this is isosceles, which means that this angle right here, the base angle, that one, and then this one, those should be the same. So we already have 58 degrees, so if I do 180, subtract 58, that gives me 122. Okay, so I know that these two angles right here have to add up to 122, and because they're the same, I can just divide that by 2 to find each one. So 122 divided by 2 gives us 61. So each of these angles that I marked in yellow here are 61 degrees, because the base angles of the isosceles triangle are going to be the same. Okay, so we have 61, 61, and 58, and if you do add those up, they do add up to 180, so that's good. And because all these triangles are going to be the same, just kind of flipped and flopped and whatnot, this one right here should be 58 degrees, because that's a vertex angle. This right here is a base angle, so that should be 61 degrees. So your whole angle BCD is going to be 61 plus 58, which comes out to be 119. Okay, so BCD is actually 119, not 120, so it's 1 degree smaller than the one we did in the previous example. Okay, and that is all I have about isosceles and equilateral triangles. So the main thing to remember is, for isosceles, your two base angles are always congruent. Okay, and that's kind of the main concept of this. And then if you have that information, you can usually find everything else. All right, that's all I have for today, folks. Peace out.